Hi, this is for question 5, also on barometer. Now, the first part of the question in part A asks you to state the value of atmospheric pressure in the units mmHg. So, this is the standard way of reading the atmospheric pressure using a barometer. First, you look at this point over here. This is where atmospheric pressure acts on. And since the mercury is not moving, we can easily just draw a horizontal line and argue that at the second x that I've drawn, the two pressures are the same. So pressure here and pressure here is the same. So I'll just write it as pressure of atmospheric equals to px. Because on the horizontal line, if there is any difference in pressure, then you should see the mercury moving. Okay? Therefore, what is pressure at x? Pressure at x is due to everything on top pushing down on x. So this means you have a pressure of a vacuum plus a pressure of mercury. And therefore, pressure of vacuum is 0, and you have this type of mercury, which is 800 mm minus away 50 mm. That's how you can get the answer, 750 mm Hg. Alright. Now, in part B, if we add more mercury into the part B, into the area B, just by simply pouring more mercury inside, what will happen is this. The mercury level at B will definitely increase. Okay, so if you are being told that the mercury level in A rises by 5 mm, the mercury level at B will also rise by 5 mm. The premise here is because the difference in level of mercury, which is what we got just now as 750 mm Hg, tells us about atmospheric pressure. Since atmospheric pressure didn't change, I mean, you leave the barometer there, the earth didn't stop spinning or whatsoever, atmospheric pressure didn't change, the difference in height in the mercury must still represent atmospheric pressure, which is 750 mmHg. So no matter how much mercury we have, the levels can be very high or very low, but the difference in the level will be kept at 750 mm. Okay, so this is for part B. So a mercury barometer actually doesn't depend on the amount of mercury inside, because regardless of the amount, the difference in the level in the barometer will reflect the atmospheric pressure. In part C, if the barometer is 40 and we introduce some air into the space above A, which is supposed to be a vacuum, the difference in mercury level now will be altered, as the question stated, to 600 mm. The objective is to determine the pressure of the air in Pascal. So let's go back to the diagram. And if your vacuum here becomes air, you are told that this difference in height now becomes, which I can't remember, 600 mm over here. So this becomes 600 mm. So let's use back the same equation. P atmosphere equals to Px. And we know that the pressure of the atmosphere didn't change. So just write down your answer, 750 mm worth of mercury. And pressure X now at this point, again, is due to pressure of everything on top of it pushing down at point X. So this means now instead of the pressure of the vacuum, we have pressure of air plus the pressure of mercury. All right, and we are given that this pressure of mercury is now 600 mmHg, leaving us just one unknown, and hence pressure of the air is 150 mmHg. All right, and this is for question